Alright, so for this problem, a dental insurance company pays 100% of the cost of fillings and 70% of the cost of root canals. Fillings and root canals cost $50 and $500 each, respectively. The tables below show the probability distributions of the annual number of fillings and annual number of root canals for each of the company's policyholders. So it's pretty well laid out here. Of course, each of these need to add up to 100%. So our problem is, the question is, calculate the expected annual payment per policyholder for fillings and root canals. So in other words, the annual expected costs that the dental insurance company is going to have to pay out for all the fillings and root canals they expect to deliver or administer in a given year. So here's how I solve this problem. Just rebuilding the above table here. So left column is the number of fillings. The second column here is the probability of the filling happening, just per the table above here. And now doing the same thing for the root canals. EX is the expected value of X, which is the number of fillings times the probability of said filling. So 0 times 0.6 is of course 0, 1 times 0.2 is 0.2, and you get the idea. Continuing on for the other table, and now just adding some formatting here. And now the next thing we need to do is figure out the cost, which 0 fillings would have obviously cost $0. And the cost 3 fillings be $150 at $50 each. Paid by the insurance would be 100%. That's what's remaining for the consumer to pay. And then finally for the root canals, one root canal is $500, 350 of which is paid by the insurance. And at this point I thought I was done, but no, of course, not a single SOA problem is easy. They're not supposed to be easy. No, it's supposed to mess with your head and just cause you to doubt yourself and hope that you quit, but not this guy. No. I'm going to tell you why I'm not quitting. This is why. So just gotta hang in there. It's a long haul. It's going to be very rewarding, I know it. Alright, continuing on here. So now that I know that it's not 650, I tried a couple different things to solve the problem. So I switched, actually what I did right now is just switch the locations of the cost and the expected value. I swapped this column for that column and recalculated everything. So the expected cost is actually going to be the cost per filling times its probability. So $50, one filling, $50 times 0.2 gives you expected cost of 10. And I just filled out the rest of the table. Now the second table, we've got to do the same thing here. So one root canal has an expected cost of $100. So now we recalculate everything here. And there is your answer. $102.50 per policyholder per year is the expected cost of fillings and or root canals. We're going to have to fix this formula too as well. So these are paid out at 100%, just equal that guy. Actually, that's not true. Just paid out at 100%, just zeroed it out, and then so paid by the insurance, this would obviously have to be 100 minus 70. So the insurance company would expect to pay $102.50 per year. But the consumer would only have to pay nothing for the fillings because they're covered at 100%. 70% coverage for the root canal, so 70-30. That's how that split would work out, using the same logic. And so that is our today's lesson. Thank you.